All right, Algebra 1. So this is Algebra 1. And these are our notes. So you guys are going to take notes exactly like I do to get credit. This is section 3.5, graphing linear equations. We've graphed linear equations before. Something new though, graphing linear equations in slope intercept form. All right, make sure you put your name, date, period, title it. So, and if you at any point need to pause it, catch up, write what I'm writing, you should pause the video. All right, graphing linear equations in slope intercept form. So let's first talk about what slope is. So slope is it's how steep a line is, and if it's going up or if it's going down. So if the slope is positive, that's one of four major categories. So we're going to have positive, negative, 0, and undefined. So these are the four major categories of slope. So if it's positive, it's going uphill, right? Goes uphill left to right. So we generally think left to right. That's sort of like the normal way of thinking forwards in math, looking at graphs, left to right. Goes uphill. It's negative, goes downhill, left to right. 0 would be flat, right? But you have a special name for that. It's called a horizontal line. Right? It's horizontal, it's flat, it has no slope. So slope is steepness, right? So if something's not steep at all, then it's flat. Undefined is infinitely steep. Infinitely steep. It is so steep, we can't give it a number. It's undefined, okay? And that's a vertical line. So those are the four kind of major categories. You might be asked to identify if the slope is positive, negative, 0, or undefined. Let's talk about how we find the slope. Okay, and there's a few different ways. Now, we usually use the letter N to represent slope, kind of a shortcut, so we don't have to write the word slope. But we'll start with rise over run. Rise over run. And so that's sort of the major idea, rise over run. So rise is up and down, right? Run is left to right. And we usually go left to right. We can go backwards, but we just got to be careful. So rise over run. So up and down, well, that's the change in y. Y is an up and down variable. So change in y is how far up you go from one point to another. The change in x is how much you go over left to right. So change in y over change in x. As a formula, you would write it y2 minus y1 to get the change in y, difference in y, over x2 minus x1. So that's sort of a formula that we can use. And we'll use some of these in different ways. So, example 1, you're going to have some problems that just say, find the slope. Find the slope. But it'll be given to you in different forms. Okay? So, example A, you might be given a picture of a graph. So, let's draw one here. Now, it might be easier to use graph paper for some of these problems on this assignment, but it's not absolutely necessary. So I'm going to put a point right here, labeled 3, 2. It matches up with 3 on the x, y on the 2. And I'm going to do one over here to the left 3, down 2. We're going to call that -3, -2. So you always leave with the x and the y. And then there would be a straight line, which now this would already be given to you. But we're going to go ahead and draw this. Now, if you're careful, it should go through the origin. And we usually put arrows on the ends of the line. So this would already be given to you. And they say, find the slope. You say, okay, well, we could do rise over run, right? We could use that formula. We could just count the squares. How far up do you go from this point to that point? You can say, okay, you could actually count. If you had graph paper, it's even easier. 1, 2, 3, 4. We went up 4 to get from here to there, and then over 1, 2, 3, 4, 5, 6. Over 6. So we went up 4, positive, over 6, positive. And then we should go ahead and reduce it. So the slope is 2/3. And we'd say that that's a positive slope because it's a positive number, first off, right? It's a positive number, which should always match a graph that's going up from left to right, going uphill. So that's one way we can do it. That's one kind of problem. You might be given a pair of points, 0, 2, 2, -1, and you might need to find the slope between those points. So in this case, it might be good to use our formula right here because we have 2 points. We could say, well, we're going to do y2 minus y1 over x2 minus x1. And to help you, it might be good to go ahead and label these. One of these points you're going to write x1, y1, and one of you write x2, y2. I'll probably just do the first one is x1, y1, and the second one is x2, y2, but you can switch it. Your work will look a little different, but you get the same answer in the end. So y2 minus y1, you might draw some lines here. y2, -1 minus 2 over x2 minus x1, 2 minus 0. Key thing is you better start with the same point on the top and the bottom. So you can make this your x2, y2, but -1 minus 2 is -3 over 2. So the slope is -3 halves. And that is a negative slope. And if you were to graph it, it would look like it was going down. So that's another way you could be given a problem. Another way is you could be given a table. So let's see, 4, 7, 10, 20, 14, 18. I think maybe the easiest thing to do is to just write a couple of these points as ordered pairs. So you could say, okay, well, one of them is 4, 20, and another one is 7, 14. And you could do your rise of run. You could say, okay, well, you could label them if you want, x1, y1, x2, y2. So y2. So I'm going to go ahead and use this formula again. So y2, 14, minus y1, 20, over 7, x2 minus x1, 4. 14 minus 20 is -6 over 3. And your final answer is -2. And you get a negative slope. So that's how you can do the table. We'll do one more with the table. Now, just say, and by the way, you can use any pair of points on it. You could use this one, this one, this one, this one, this one, this one. It should all come out the same. And like another thing is that to get from here to here, you add 3. You add 3. That's like your ride, or that's your run. This is your rise over down 6. Oops, hold on a second. should be an 8. Should just be down 6, down 6. So you can do rise or front. Negative 6 over 3 is negative 2. Let's do one more. Negative 1, 1, 3, 2, 2, 2. This one's kind of interesting. So you could write down a couple points, any 2 points, whatever you want. And we could do, okay, we'll rise, change in y. So we do 2 minus 2, this minus this, over this minus this. Now be careful, 1 minus negative 1. I like to put parentheses around that. 2 minus 2 is 0. On the bottom, though, this is 2. Now, 0 divided by 2, 0 divided by anything is 0. So that's a 0 slope. Flat line. So you're going to have some problems like that. Let's look at some other potential problems. Example 2. So we're going to start with slope-intercept form. So we haven't really talked about slope-intercept form yet. We just talked about slope on its own, right? But slope-intercept form is y equals mx plus b. And m is the slope, and b is the y-intercept. And they're going to be numbers. So an example could be find the slope and y-intercept. And you could be given equations. Y equals 3x minus 4. Find the slope and the y-intercept. Don't need to graph it. Just find the slope and the y-intercept. So if we can get it like this, then it'd be really easy to tell why. And so it might be helpful too to even write underneath it. Y equals mx plus b. So m is 3. And b is negative 4. B is the y-intercept. If there's a minus in front, that's going to be negative. Let's try another one. Make it a little more interesting. Y equals 6.5. Now, the goal is to write it like this. Y equals mx plus b, some number times x. Well, there is no x. I don't know if you guys remember this from the previous section. Well, that's the same as 0x, right? If there's no x's, that's 0x. Plus 6.5 is the number over here. So your slope is 0, and your y-intercept, which we often call b, is 6.5. So you got to get a little creative. C, negative 5x minus y equals negative 2. Now, we need to try and get in slope-intercept form. By the way, you're going to want to get in slope-intercept form so you can find the y-intercept and slope easily, so you can make your graphs easily. Sometimes the equation will not be in slope-intercept form, so you got to move things around. So if you want to get the y by itself, right? Get y by itself. Get it in the slope-intercept form. So we got to solve. So you got to get rid of the negative 5x, add 5x, get rid of addition and subtraction first, reverse order of operations. The negative is still there. Now we cannot combine these. They're not like terms. So we got to keep the negative 2 and the 5x separate. I'm going to put the 5x first because I'm trying to make it look like this, and then the minus 2. Right? Because my goal is to make it look like y equals mx plus b. Now we got to get rid of the negative. We got to divide both sides by negative 1. It's like a negative 1 there. And that's going to be negative 5x plus 2. Make sure you distribute the negative 1 division. And so your slope is negative 5, and your y-intercept is 2. Okay? Okay, example 3. On these ones, we are going to use slope-intercept form to graph the line. So now we're going to actually do some graphs. Now, if you have graph paper, it can help. Don't have to. So we're going to do 3 examples. 2x plus y equals 2. So the first thing to do is to get it in the slope-intercept form. And if it's not, you got to get the y by itself. So you got to subtract 2x from both sides. Y is still on the left. I'm going to put the negative 2x first, and then the other 2 is positive, so I write plus 2. So I get it in slope-intercept form. And so then your slope is negative 2, and your y-intercept is 2. If you have those two things, it's pretty easy to draw a quick graph. Now, we do expect this graph to be going downhill left to right, okay? Now, let's make a graph. So you can use graph paper. Otherwise, be very careful. Try to draw straight lines. Now, I'm gonna make some little marks. Try to make them equally far apart from each other. So we're going to plot graph. Plot is a fancy name for graph. Graph the y-intercept first. Okay. And it's a y-intercept, so it's where it crosses y. So you go up 1, 2. That's your y-intercept. That's also the point on your graph. So start there. That's the y-intercept. All right. Maybe put the number next to it. And then the slope is negative 2. So these are going down. We want to think of as rise over run though. So negative 2 is the same thing as fraction, negative 2 over 1, right? So we do that. So we're going to go down to right 1. We always go left to right in general if we're going forwards. And let's get another point, down 2 over 1. If you have 3 points, it makes your graph a lot better than just 2 points. It makes it more accurate. So the more points you have, the better it is. But at some point, it's also probably not going to give you that much benefit. Like draw arrows, get a ruler, get something straight. Now, they could ask you, what's the y-intercept of the graph? You could say, well, it's 2. You might also say it's 0, 2, right? X coordinate 0. You might also be asked, what's the x-intercept? Well, the x-intercept is where it crosses the x-axis, right? The y-intercept, intercept is a fancy word for cross. So you can see it right here. If you've done a good job graphing, the coordinates at that point are 1, 0. That's the x-intercept. X first, y second, 1, 0. Okay? Let's try a couple more. B. 3x plus y equals negative 3. We got to get in slope-intercept form. We got to get that y by itself. So we're going to subtract 3x. I'm going to put the negative 3x first and then the minus 3. So we're in slope-intercept form. So the slope is negative 3. The y-intercept is negative 3. Now, you could also think when you go to make this graph is going to be further down below, and it's going to have a negative slope, so it's going to keep going down. So when I go to graph it, I might give myself more room below the x-axis just to fit the graph better. Yeah. So 1, 2, 3. So that's going to be the y-intercept, is that negative 3. Now, the slope is negative 3. We're going to think of it as a fraction, negative 3 over 1. From here, we're going to go down 3 over 1. And you can get another point, down 1, 2, 3 over 1. But you might run out of room down here. You might want the x-intercept. So we could go backwards, and backwards would be up 3, left 1. It's like you apply the negative to the run instead of the rise. We usually think of the rise, so up or down. Positives up, negatives down. And we always go left to right, but we could go right to left, apply the negative to the bottom. But it should look like it's all in a straight line. Connect it, nice straight line, ruler, something straight, put arrows on the ends. So this is the y-intercept, -3. You might also think it's 0, -3. The x-coordinate is 0, the y-coordinate is 3. This is the x-intercept. Coordinates would be -1, 0. All right, last one. Y equals 2x plus 4. Now, this one's already in slope-intercept form, right? So, slope is 2, y-intercept is 4. This graph's going to be a little taller, so I might give myself a little more room up above. 1, 2, 3, 4. So that's the y-intercept. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Slope is up 2 over 1. So I'm going to go up 2 over 1. Up 2 over 1. Now, maybe we want the x-intercept. So we can go backwards. We go down 2, left 1. Down 2, left 1. And so we get a nice x-intercept. So let's see, we connect it with a straight line. Arrows on the ends. This is the y-intercept of 4 or 0, 4. This is the x-intercept, -2, 0. So that's how you graph lines using slope-intercept form. Today's classwork will be the monitoring progress out of your textbook page, starting at page 136, problems 1 through 12 all. They're at the bottoms of the pages. If it's zoomed in all the way, you can press the little blue play arrows, watch a video showing you how to do a similar problem. That will help you if you have any questions about it. That's it for today. Make sure you took all the notes. Rewind it, pause it if you need to get any of the notes you missed. And then try the assignment, the classwork assignment. That's it.